Hello there. Imagine for a moment that you are standing beneath the vast canopy of the night sky, gazing up at the stars, those distant points of light that seem to twinkle against the backdrop of the infinite. To the casual observer, these stars might appear merely as serene, quiet embellishments on a celestial canvas. However, the reality behind this seemingly tranquil scene is far more dynamic and complex. The universe is not a static panorama, rather, it is in a state of perpetual motion. Ever since the cataclysmic event known as the Big Bang, which took place approximately 13.8 billion years ago, galaxies have been hurtling away from each other at incredible speeds, a testament to the universe's expanding nature. Nearly a century ago, a profound discovery was made by the esteemed American astronomer Edwin Hubble. He observed that the vast majority of galaxies were moving away from us, a revelation that served as a pivotal piece of evidence confirming the notion of an expanding universe. Yet, even with this profound understanding, a peculiar enigma lingered, a mystery nestled within our very own cosmic neighborhood. In the realm of space that we inhabit, known to astronomers as the local group, there exists a fascinating collection of nearby galaxies. Upon close observation, astronomers notice something quite puzzling. The majority of these galaxies seem to be moving away from the Milky Way. This observation was particularly perplexing because the gravitational pull exerted by our galaxy, along with the nearby Andromeda galaxy, should ostensibly be strong enough to draw these galaxies inward. Adding further complexity to this cosmic puzzle is the behavior of Andromeda itself. As the closest large galaxy to the Milky Way, Andromeda is not moving away but rather, it is hurtling toward us at a considerable speed of about 100 kilometers per second. Meanwhile, many other galaxies in the vicinity seem to be moving in the opposite direction. This apparent contradiction has perplexed astronomers for decades. The question arises: how can gravity be sufficient to pull in Andromeda, yet appear insufficient to attract many other nearby galaxies? Was there a missing piece in our comprehension of the structure of the local universe? The answer, it seems, lies in a colossal cosmic structure whose true nature had not been fully recognized until recent times. In recent years, a dedicated international team of astronomers embarked on an ambitious project, harnessing the power of extremely sophisticated supercomputers. Their aim was to simulate the universe's evolution, tracing its development from the earliest moments after the Big Bang to the present day. This intricate endeavor sought to reconstruct the cosmic environment surrounding our galaxy with unparalleled precision and detail. What they discovered was nothing short of astonishing. These groundbreaking simulations revealed a surprising truth: matter in our region of the universe is not organized in a simple spherical manner around the local group. Instead, it is arranged in an expansive, flattened structure that resembles a giant sheet or slab. This cosmic sheet, as it is now known, stretches across tens of millions of light-years and includes the Milky Way, Andromeda, and many other neighboring galaxies. Yet, this sheet is not composed merely of visible stars and galaxies. In fact, it largely consists of something far more enigmatic: dark matter. This mysterious form of matter is invisible, emitting no light and reflecting none, yet it constitutes about 85% of all matter in the universe. Although we cannot see it directly, its gravitational influence is pivotal in shaping the structures of the cosmos. According to the new models, dark matter in our region is concentrated into an enormous flattened layer surrounding the local group, as if our galaxy were resting on an immense unseen cosmic platform. The most thrilling aspect of this discovery is not only the existence of the cosmic sheet itself but also the vast, almost empty regions that lie above and below it. Extending on either side of this sheet are vast expanses of space that are nearly void of galaxies, known to cosmologists as cosmic voids. These voids contain far fewer galaxies than the average parts of the universe. In the realm of cosmology, voids are not simply empty gaps devoid of matter. Rather, they play a crucial role in influencing the motion of galaxies. When a particular region of the universe has a significantly lower density than its surroundings, matter tends to move away from that underdense region and toward the denser areas of the cosmos. In our particular situation, these massive voids appear to exert an influence on the giant sheet that contains our galaxy. As a result, many neighboring galaxies drift away from the local group, not because some mysterious force is actively pushing them outward, but because they are responding to the complex gravitational landscape created by the uneven distribution of matter across the region. In essence, what we are observing is not solely the expansion of the universe, but also the effect of a much more intricate cosmic arrangement of matter and void. When we observe the galaxies that are relatively nearby, most of them seem to follow what astronomers term the Hubble flow, the large-scale motion that is driven by the ongoing expansion of the universe. However, scientists notice that in our local region, this flow appears calmer and more orderly than what older models had predicted. The gravitational pull of the local group should have caused far stronger disturbances in the motions of nearby galaxies than what is currently observed. The newly identified cosmic sheet provides a compelling explanation for this long-standing puzzle. Galaxies that are embedded within the sheet appear to move along a broad, flattened plane, while the cosmic voids that lie above and below this plane remain almost devoid of matter. This particular arrangement allows galaxies to recede along relatively smooth and predictable paths, without being subjected to the kind of intense gravitational chaos that would be expected in a more cluttered, three-dimensional environment. One might imagine it as galaxies traveling along a wide and level cosmic highway, as opposed to navigating a tangled and turbulent three-dimensional field of gravitational forces. Yet, even with these revelations, one question persists. Why is the Andromeda Galaxy moving toward us when so many others are moving away? The explanation lies in its unique position within the same cosmic sheet. The Milky Way and Andromeda together form the central core of the local group, and they are by far its two largest galaxies. Their immense masses create a mutual gravitational attraction that is strong enough to overcome the local effect of cosmic expansion. This is why, even though the universe is expanding as a whole, these two galaxies are slowly converging on a cosmic scale. Current calculations suggest that this monumental encounter will occur in about 4 billion years. At that time, the two galaxies are expected to merge, forming a single, giant galaxy. Until then, many other nearby galaxies are expected to continue drifting away along the cosmic sheet. This discovery accomplishes much more than merely explaining the motion of nearby galaxies. It introduces a significant new piece to the broader puzzle of how the universe is structured. Over the past few decades, astronomers have come to realize that the distribution of matter in the universe is not random. Instead, it resembles an immense structure known as the cosmic web. This cosmic web consists of long filaments of galaxies and dark matter, intersecting at dense knots that contain galaxy clusters. Between these filaments lie the enormous cosmic voids. The sheet that contains our galaxy now appears to be a part of this vast web, akin to a wall or layered structure within the greater cosmic architecture. This implies that the location of the Milky Way in the universe is not random at all. It is part of a gigantic geometric pattern that extends across hundreds of millions of light years. Achieving this discovery was not possible through telescopes alone. Instead, scientists relied on extremely sophisticated cosmological simulations. These simulations began by constructing a model of the early universe, based on highly precise measurements of the cosmic microwave background, the faint remnant radiation left behind by the Big Bang. They then used supercomputers to simulate how the universe evolved over billions of years, accounting for the effects of gravity and the mysterious presence of dark matter. By running hundreds of different scenarios, they were eventually able to produce a model that closely matches the real cosmic environment surrounding our galaxy. Scientists sometimes refer to this type of reconstruction as a virtual twin of the local universe, because it replicates the positions and velocities of nearby galaxies with remarkable accuracy. The significance of this discovery lies not only in resolving an old mystery, but also in paving a new path toward understanding the nearby universe. If our galaxy is indeed embedded inside a sheet of dark matter, then the distribution of matter around us may be more structured and intricate than we had previously imagined. These findings could also aid astronomers in refining the cosmological models used to explain how galaxies form and evolve over cosmic time. Perhaps most importantly, they offer a new approach to investigating dark matter itself, that elusive substance that constitutes most of the mass in the universe and yet remains one of the greatest unsolved problems in modern physics. When people gaze up at the night sky, they often feel that Earth is merely a tiny speck in an endless sea of darkness. Yet, science continues to add new layers of meaning to that sentiment. We do not merely reside inside a galaxy or even within a small group of galaxies. We exist within a vast cosmic structure of dark matter and galaxies stretching across tens of millions of light years. It is a giant cosmic sheet, and our galaxy seems to rest upon it like an island in an invisible ocean. And perhaps, in the near future, new studies will reveal that this sheet is only a small part of an even greater structure, one that spans the universe and connects billions of galaxies in a single cosmic fabric. Each time scientists uncover something new about that fabric, we move one step closer to answering one of the greatest questions humanity has ever posed. What is the true shape of the universe? And where exactly is our place within it?